Imagine a place where stars are born in the dark, where light is born from the cold. This is the Spiral Nebula, a celestial womb of cosmic creation. These nebulae are not just clouds of gas. They are the cradle of new stars, the birthplace of light in the universe. But how do these stars form? What secrets are hidden in the dust and gas of these cosmic nurseries? Every star that shines in the night sky began its life in a place like this, where gravity, radiation, and time conspire to forge light from darkness. In this video, we'll unravel the mysteries of spiral nebulae and how they shape the destiny of the universe. So what exactly are we talking about? Spiral nebulae, those swirling, luminous clouds of gas and dust in space. They're like cosmic nurseries, where new stars are born from the chaos of collapsing gas. These nebulae are not just beautiful. They're fundamental to the life of galaxies. They're the cradle of star formation, where gravity pulls gas together into dense knots that eventually ignite into stars. Each star that forms from a nebula is a cosmic miracle. These stars can range from massive blue giants to smaller red dwarfs, each with their own story to tell. But these nebulae are more than just star factories. They also contain heavy elements, remnants of previous generations of stars, which are essential for planetary systems and life itself. So, when we look at spiral nebulae, we're not just seeing beauty. We're witnessing the birth of stars, the building blocks of planets, and the very foundation of life in the universe. You might think spiral nebulae are just beautiful cosmic art, but they're actually the birthplaces of the stars that light up your world. Every star you see in the night sky, including our sun, was once born in a nebula like these. Understanding how these nebulae form stars helps us trace the history of our own galaxy, and ultimately, our place in the universe. These cosmic nurseries are the roots of all the light and life we know. By studying these star-forming regions, we're not just learning about the cosmos, we're learning about ourselves. Every star, every planet, every life form is connected to the same cosmic process that birthed the universe. So, the next time you look up at the stars, remember that you're peering into the cradle of your own existence. These spiral nebulae are not just distant wonders. They're the silent architects of the universe. We rewind to the earliest days of the universe, when the first stars ignited in the primordial darkness, lighting the void with their brilliant, violent births. These stars, massive and short-lived, exploded in supernovae, scattering heavy elements across the cosmos and seeding the next generation of stars and planets. In these nurseries, gravity and magnetism conspired to spin gas into disks, where the seeds of planets formed around nascent stars. And then, the spiral nebulae emerged, vast, glowing spirals of gas and dust, where stars are still born, still forming, still shaping the universe. Imagine a giant cosmic kitchen, where stars are made like cookies. Gravity pulls gas and dust together, like dough, and it starts to get really hot. As the dough gets denser, it starts to spin, making a spiral shape, just like when you spin a pizza dough. This new star shines so bright, it starts to push the gas and dust away, just like a tiny solar system growing up and moving out. But the spiral isn't done yet. More gas and dust keep coming in, ready to make more stars, like a never-ending cosmic recipe. So, in a way, spiral nebulae are like giant cosmic ovens, cooking up stars one by one over millions of years. The spiral nebula begins as a cosmic nursery, a vast cloud of gas and dust, mostly hydrogen and helium, drifting through the cold void of space. It's a place where the universe's raw ingredients are waiting to be transformed into stars. This cloud isn't just empty space. It's filled with the potential for life, shaped by gravity, magnetic fields, and the faint whispers of stellar winds from nearby stars. At the heart of the nebula, dense pockets of gas and dust begin to clump together, drawn by gravity's invisible hand, forming the seeds of future stars. These clumps are not just random. They're shaped by turbulence, rotation, and magnetic forces, creating a dynamic, swirling structure that sets the stage for star formation. As the cloud continues to collapse, it begins to spin faster, forming a rotating disk that will eventually give birth to a star and its surrounding planetary system. Once the shockwave from the dying star reaches the surrounding gas, it compresses the interstellar material, triggering a chain reaction of gravitational collapse. This compression raises the temperature and density in certain regions, creating the perfect conditions for gravity to take over and begin the birth of new stars. Within these clumps, gravity pulls the gas and dust together, forming dense, hot cores that will eventually ignite nuclear fusion. As the core heats up, it becomes a protostar, a glowing ember in the dark, and the first light of a new star begins to flicker. This process, driven by the remnants of a dying star, is a cosmic cycle of destruction and creation, where the end of one life births a new beginning. Now, the spiral arms act like cosmic highways, guiding gas and dust toward the center of the galaxy. These lanes are packed with material that's just the right density and temperature to spark new stars. But here's the twist. The spiral pattern itself is a kind of gravitational illusion. It's not just the arms that guide the material, it's the entire structure of the galaxy, shaped by its own rotation and gravity. This rotation creates a kind of cosmic spiral staircase, where material spirals inward in a slow, deliberate dance. As it moves, it condenses, cools, and forms the dense clouds that will eventually become stars. And just like a whirlpool in the ocean, this spiral motion is more than just movement. It's a mechanism. It channels energy and material in a way that makes star formation not just possible, but efficient. So the spiral isn't just a pretty pattern. It's a cosmic engine, turning the galaxy's rotation into a force that fuels the birth of stars across the universe. At the heart of these spirals, gravity and magnetism weave a cosmic dance, pulling gas and dust into twisting filaments, where stars are born in a celestial ballet. Molecular clouds, dense and cold, are the nurseries of stars, where gravity slowly condenses gas into clumps that will collapse and ignite. The magnetic fields in these regions act like invisible ropes, guiding the flow of gas and influencing how stars form in clusters or isolation. Every star that forms in these nebulae carries the echoes of cosmic forces, from gravity to magnetism, shaping the life of a star and its planets. This is the science humming in the heart of the spiral nebulae, where the universe crafts stars one by one in a slow, steady cosmic rhythm. Imagine a giant cosmic salad, where stars are the dressing, gas is the lettuce, and dark matter is the invisible hand that stirs it all together. This salad isn't just pretty. It's a recipe for creating stars, one ingredient at a time, in a slow, elegant dance of gravity and chaos. Just like a salad needs the right mix of ingredients, a spiral nebula needs the right mix of gas, dark matter, and gravity to form stars. So when you see a spiral nebula, think of it not as a pretty picture, but as a cosmic kitchen, where stars are born one by one in a slow, beautiful process. And just like a salad, it's not about the end result. It's about the process, the ingredients, and the way they come together in the vastness of space. Before you go, if you enjoyed this, please give it a like and subscribe so you don't miss the next one. And tell us in the comments what you'd like us to make next. We read every single one. Thank you so much for watching. Comment this emoji if you made it to the end.